In this session, let us try to understand open delta connection. Basically, open delta connection, the advantage is in a shortcut way, in a very shortest possible time, we will be able to get some conclusions, but not detailed conclusions. Okay, and in order to have detailed conclusions, intricate analysis is required. First of all, let me cover up in a shortest possible way. And let us get some two conclusions will be there. Anyway, hope you might know all those two conclusions. Okay, and beyond that, intricate analysis immediately I'll try to do after this. Okay, now let me think of 4 voltage sources connected here. Okay, normally ideal DC voltage sources are connected in a closed loop. Let me think of this as 20 volts. Let me think of this as 5 volts. Let me think of this as 15 volts. Let me think of this as 10 volts. Just like that. Now in a closed path, see here, voltage rise of 20 volts, voltage rise minus to plus is 5 volts, 25 volts, voltage drop of 15 volts, voltage drop of 10 volts. So net voltage is 0, KVL is satisfied. KVL is satisfied in the sense conservation of energy or conservation of power is satisfied. Now let us think of here, how much will be the voltage? Voltage is going to be directly voltage source is there, 10 volts. Now, for example, if I remove this voltage, source, how much will be the voltage across this? In the sense, this particular thing is removed. Then also, voltage will be 10 volts only, no? Because minus of this voltage, or this voltage equal to minus 5 plus 5, minus 15 plus 5 plus 20 is going to be 10 only, no? Okay, what is the conclusion we can get from here? The conclusion is very simple. In any way, means in any closed path, connected by only independent sources, voltage across one independent source is independent of existence of that in the network. Okay, if I connect this particular 10 volts also, voltage across this will be 10 only. If I remove this also, in a closed path, like I have to apply KVL and I will get the same voltage. So in a closed path, in a closed path formed by independent voltage sources, in that conditions, even if you remove one voltage source, voltage across that will not change. Okay, now let us apply the same to the delta connection. Okay, if I think of delta connection, see here, this is delta, right? Now delta connection of the transformer. And what is the first and foremost assumption in the analysis of transformer or in the analysis of motor? It should be connected with the ideal voltage sources. Okay, and this is delta connection of the primary of the transformer, this is delta connection of the secondary, and the secondary can be connected to 3-phase load. Okay, about the loading and all we will see later. Now, basically here to here voltage, or here to here voltage, or here to here voltages are supplied by ideal voltage sources. And if you consider ideal transformers, okay, then voltage across this equal to voltage across this, voltage across this, voltage across this. If I think of A here, B here, C here, okay, now if I write equation in the closed path, because it is connected by sources only, no? So this is going to be VAB plus VBC plus VCA equal to 0. In that way, 120 degrees displacement and all will be there, you know, I know. Okay, now let me remove one of the phase. Let me remove one of the phase winding. Then also voltage across this will be same only, no? Okay, so if I think of plus here minus here, this is going to be VBC. Okay, means already notation you know from network theory. If I think of VAB, meaning that VA voltage with respect to B. Okay, so with respect to B, A is at how much more potential. So with respect to C, how much is the B potential is going to be VBC. Second term is going to be reference. With reference to C, how much is B voltage is going to be VBC. Okay, now if I think of this VBC, how much is VBC? Even if I remove this, I have to apply KVL same. So this is going to be minus of VCA plus VAB. It will not change. Okay, so if I have this, anyway closed path is going to be 0. And if I remove this, provided only one condition, my transformer should be connected with ideal voltage sources. If transformer is connected with ideal voltage sources in a closed path, ideal voltage source are connected. If I remove one of the voltage source also, nothing is going to happen. Okay, similarly here I can remove this. If I consider this as maybe A, B, C, So the moment the primaries are connected to ideal voltage sources, secondaries also, provided if you neglect that leakage impedances, shunt branches, if you neglect everything and if you consider transformer as ideal transformer, under that condition, if this voltage cannot be changed, this voltage also cannot be changed. Okay, so these are also kind of ideal voltage source only. So even if you have this third winding or not, voltages across this will not change. Voltage across this will not change. So without having this, without having this particular transformer, we will be able to operate such that if you supply balanced three-phase voltages, you are going to get the output at balanced three-phase voltages. That's it. Now, where is the application of this? Okay, where can you use this? If I have, normally, if you given a chance, will you use three-phase transformer or three-phase transformer bank? Because, let me have a small recap. If I have all three phases inside one transformer tank, okay, so this is going to be transformer tank. This is called as a three-phase transformer bank. Oh, sorry, three-phase transformer. If I have three individual transformers, in this is three different transformer tanks, then I can call this as a three-phase transformer bank. Now, if you are given a chance, will you choose three-phase transformer or three-phase transformer bank? Obviously, three-phase transformer. Okay, because three-phase transformer volume of iron requirement will be less, and many things we discussed, right? Core type, shell type, something like that. So in three-phase transformer, if you combine all the phase windings inside the only one transformer tank, volume of core requirement will be less. If volume of core requirement is less, price will be less. Okay, so unnecessarily we don't go here. For example, in this, if it is connected in delta, if one of the phase went to faulty condition, one of the phase winding, some fault happened. Of course, having fault in transformer is very rare. Okay, because in any case, if I have substation, at the input of the substation, lightning arrestor will be there, at the output of the substation, lightning arrestor will be there. So from outside, surges may not enter into the any substation. Okay, but inside maybe some faults can happen. We cannot say that my transformer is completely maintenance free. It is least maintenance, we can say, in machine, means out of all machines transformer is least maintenance, but I cannot say maintenance free. So maybe some fault can happen here, or in this case, okay, ultimately these two are going to be connected in delta, these two are going to be connected in delta. So in this case, for example, if this transformer fail, then okay, what can happen in this case? Okay, because some fault happened here, so I can remove this and I can send it for the repair work, and remaining two transformers, by having remaining two transformers, I'll be able to maintain three-phase power. Obviously capacity will be reduced. Okay, if I have this as 10 kVA, okay, the moment I'm going to remove this, how much will be the installed capacity? 20 kVA. Maybe we are going to see in means very soon how much capacity can be withdrawn, but of course the moment one transformer is not working, that particular kVA nobody will take. Okay, so in this case this particular transformer can be removed and can be sent to repair work. Okay, but in this case the moment one of the phase winding failed, we cannot we cannot go inside and we cannot remove that particular transformer and send it for repair work. So in this case only open delta connection is possible, okay, for a longer period of time, maybe for very short duration of time. Okay, very short duration of time, the moment this particular section got some faulty section, okay, so remaining two transformer phase windings can be operated in open delta connection. But in that condition, again one more new transformer delta connection should come. That particular delta should be connected here, and then complete transformer has to be going for replacement. Okay, that is one thing. And anyway, if you are given a chance, you are going to choose this only, not this. Means whenever you have this for short time till you get the replacement of delta transformer, means another transformer, till you get the replacement of another transformer, for short duration of time we can maintain. But the moment here, okay, so the moment I remove this transformer, remaining two transformer can continue to work. Okay, now this transformer can go for repair work, and a bit longer duration you can maintain if it is three-phase transformer bank. But where do we use three-phase transformer bank? Okay, see here, if you have huge capacity of load or huge capacity of demand, okay, maybe in a single transformer tank, maybe up to 3 MVA I can design, for example, up to 3 MVA. Now in this case, for example, if three-phase load is maybe 10 MVA, okay, so up to 3 MVA in a single transformer tank I can design. For example, it is going to be 5 MVA. Okay, so in a single transformer tank, 3 MVA is the maximum capacity, meaning that each and every phase has to bear roughly 3 by 1. Okay, so the 1 MVA has to be delivered. If you think of here, for example, if this three-phase capacity is beyond our level, which can be installed in a single transformer tank, you are forced to have 3 transformers. Okay, so if it is beyond our design capability as a single transformer tank, in a single transformer tank, under that conditions we are forced to operate with three-phase transformer bank. Can be generator transformer. Okay, so at the generator side huge power will be there. So in order to manage huge power, rather than having all 3 transformers in a single transformer tank, we are going to divide. Okay, if you think of very high, very huge power transmission capability of any substation, under that conditions, rather than having this, you may have this. Okay, for example, 220 by 440 kV line is there in power system. In 220 kV by 440 kV line, under that condition, all these 3, because obviously voltage levels are high, my bulk of power is going to be so high. In that case, we may not be able to design all 3 transformers in a single transformer tank. We are going to divide. Okay, then only it will be useful. Now, next thing is, the moment, for example, this is the case. In this case, I can remove this. Okay, that flexibility will be there. Okay, but one advantage I can say here, if I have 3 transformer tanks, in the sense transformer bank, what should be the reserved capacity for this backup? Okay, for example, this is maybe 5 MVA. This is 5 MVA. This is 5 MVA. Okay, my capacity backup should be there. So out of these 3 transformers, how much should be the backup capacity? Because these 3 transformers may not be able to develop the fault at simultaneously. Okay, so maybe one of the transformer may fail, so my backup can be only 5 MVA transformer. Okay, now rather than this, if I design here, okay, all 3 transformers in a single tank, so this capacity is going to be 15 kVA or 15 MVA. Okay, then what should be the backup required is going to be 15 MVA backup is required. Okay, if at all, if it fail, backup should be 15 MVA. If at all one of the transformer fail, backup is going to be 5 MVA. Okay, so means some advantages are there for 3-phase transformer bank, and some advantages are there for 3-phase transformer. For 3-phase transformer, volume of core requirement will be less, or cost is going to be less. Okay, but if you think of here, initial cost will be more, but backup requirement is going to be only 1 single phase transformer capacity is only required. Okay, anyway, point here is we will be able to operate transformers in open delta. Okay, let us think of in open delta. Okay, if I think of, see, closed delta first, closed delta. In closed delta, let me compare this particular closed delta with open delta. This is the load. Okay, star connected is the load, for example. Okay, now if I supply rated voltages here, and if it is absorbing rated kVA, okay, whatever may be the volume of copper you utilized in the design, or whatever may be the volume of iron you utilized in the design, complete thing has to be utilized. Okay, so whatever may be the design things are there, it has to be completely utilized, meaning that whatever may be the capacity of this, the same capacity should be absorbed. Okay, so means in order to have in order to utilize volume of insulation, rated voltage has to be applied. In order to utilize volume of copper, rated currents has to be flown. Okay, so phase currents are rated, meaning that here it is going to be √3 times rated currents. In three phase, what is the power? Means power in three phase or MVA or KVA, whatever it may be, in three phase is going to be root 3 VL IL. Okay, so this is going to be root 3 phase voltage per phase. I'm trying to analyze. Okay, for how much is the phase voltage or line voltage in delta connection is going to be same or V rated. Now if I think of how much is the line current, root 3 VL IL, line current is going to be with respect to phase root 3 into IR is going to be 3 V rated. I rated is the capacity of this particular transformer combination. Okay, now for example, let me remove this particular winding. Okay, so if I remove this particular winding, voltages will be same. Okay, but if you think of currents, okay, now means if this phase volume of copper is being utilized at rated current, in this how much will be the current here? Rated current. Okay, now S of open delta for three phase power, what should be the capacity of three phase? Is going to be root 3 line voltage, line current. Now if you think of root 3, phase voltage is nothing but line voltage. Is going to be V rated into how much would be the line current here, or line current here. Okay, line current is going to be phase current only, no? Okay, now of course in AC direction doesn't matter. Okay, I can show in any direction because AC 0 to positive max, 0 to negative max, 0 to positive max, in that way. So current is going to be maximum. How much will be the magnitude of current that can flow through this? Rated current only can come here. I'm not focusing on here. Okay, because in order to conclude that, means if this is rated, this also should be rated current only. In order to conclude that, intricate analysis required. Okay, but let me cover up that with kind of sophisticated terminology. Load is always balanced, no? For balanced load only we are going to analyze in our machines. If it is unbalanced, power systems, symmetrical components. Okay, so the moment it is balanced load, whatever the current this phase is taking, the same current it also should take. But internally how it is getting divided and same current is going to come, intricate analysis we are going to do. Okay, so this is going to be how much will be the current here? Rated current. Okay, so S of open delta is going to be root 3 V rated I rated. Okay, now if I think of how much is the capacity reduced in open delta? Okay, so S open delta by S closed delta is going to be root 3 VR IR, anyway will get cancelled out. 3 VR IR is going to be 1 by root 3. How much is 1 by root 3? Is going to be 0.577. Okay, is going to be 0.577. What does it mean? It means that in S capability of open delta is going to be 0.577 into S of complete delta, or 57.7% of S of closed delta. Okay, now see here, if I have three phases, if it is having 10 kVA, three phases, if it is having 10 kVA, what is the net capacity? 30 kVA. Okay, it means if this particular, okay, let me change the color to black. Okay, if it is also closed, okay, black case. In this case, if this is designed for 10 kVA, what is the three phase capacity? 30 kVA. How much is the installed capacity? 30 kVA. And at what maximum I can withdraw the kVA capacity is 30 kVA. Okay, but if you think of now, meaning that better. Okay, meaning that in open delta connection, how much is the installed capacity? Installed capacity is 10 kVA, 10 kVA, 10 kVA, 10 kVA. This 10 kVA, this 10 kVA. So how much is the installed capacity? 20 kVA. Okay, installed capacity is 20 kVA. installed capacity is 20 kVA. Okay, but at what maximum you can use, S of open delta is going to be 57.7% of total S of closed delta. That's what we derived. Okay, is going to be, okay, let me write here, 57.7% of 30 kVA is going to be 17.32 kVA. Definitely it is disadvantage. Okay, inside if you see, basically there are two types of analysis will be there. Load can be fixed, then what will happen to the transformer? Or transformer rated capacity can be fixed. In the sense, if transformer rated capacity is fixed, automatically load is going to be variable. Okay, so I can fix this, I can vary this, I can fix this, I can analyze this. Anything is fine. Now here let me fix this capacity as rated voltage, rated current. Rated voltage, rated current. Meaning that in order to have rated voltage, rated current, my load is going to be changed, is my perception. Getting my point, right? Now see here, means if this is volume of insulation is fully utilized, in the sense rated voltage is supplied, volume of copper is fully utilized, meaning that rated currents flow. Under that conditions, what is the capacity here? Capacity here, load has to be reduced to 57.7% of three phase, or load has to be reduced to, see here, load has to be reduced to installed capacity is 20 kVA, in the sense two phases. Out of two phases of 20 kVA, you can attain 17.32 kV only. In the sense, inside each of my transformer, see here, inside each of my transformer is operating at rated voltage, rated current. Okay, in the sense rated kV it is operating. For example, under open circuit condition also rated current here, under open circuit in the sense open delta. And if I close this particular also, in this delta connection also, it is going to be operating at rated currents only, because load is going to be variable. Okay, now point here is very simple. If I have installed capacity of 20 kVA, okay, and individually it is operating at 10 kVA, individually it is operating at 10 kVA, 10 kVA, 10 kVA, but net output should be 86.6% of 20 kVA. Okay, now let us think of S of open delta by installed capacity in open delta. Installed capacity in open delta is going to be, how much is this? 17.32 by installed, because one of the transformer is not connected to the network now. One of the transformer is not at all connected to the network. The moment transformer is not at all connected to the network, that cannot be considered as installed capacity. For example, I have three-phase transformer bank. In that one of the transformer I removed and I kept for the repairing work or maintenance work. Remaining two transformers only working, meaning that remaining two transformers combined capacity is going to be installed capacity, which is connected to the supplier, which can be connected to the load. So this is going to be 86.6%. Meaning that S of open delta is going to be 86.6% of installed capacity, in this two phases, or 57.7% of three phases. 57.7% of three phases. Anyway, point here is, if we go ahead with intricate analysis, point here is, if I have this particular closed delta also rated voltage, rated current, if I open circuit this also rated voltage, rated current, in the sense each transformer phase is supplying 10 kVA. Okay, so 10 kVA, 10 kVA, if I have closed delta 10 kVA, total 30, 10, 10, 10, total capacity is 30. But now in open delta 10, 10, 20, 10, 10, 20, installed capacity is 20 kVA, but you can maximum, you can get up to 17.32 kVA only. Meaning that your investment is going to be wasted. Meaning that we don't design any transformer to be operated at open delta, because your investment will be decided by voltage, current. Voltage, volume of insulation, current, volume of copper. So ultimately, depending upon voltage current capacity only, we are supposed to invest our money in the name of materials. Okay, but now what's happening means you have to invest more, in the sense you have to invest for 20 kVA, and which can be which can be used for the maximum capacity of 17.32 kVA only. So no transformer, in no case we design any transformer to be open delta. Meaning that if already working in closed delta, then if one of the transformer finds fault, then only remaining at least 17.32 kVA we can use, no? Okay, so in order to maintain continuity of supply at reduced power handling capacity. Okay, if I have closed delta, that is going to be 30 kVA, but now if you open delta, that is going to be 17.32 kVA, but at least continuity of supply is maintaining, no? Reliability is increased, no? That's why we can use this when one of the phase developed fault. Okay, kind of that. Now let us go with intricate analysis.